And we'll just keep practicing here. We're at the top of page 3 for the notes for 7.3. Same instructions: factor each trinomial or state that it's prime, multiply to check. And I don't believe you can see all the steps here on the notes, so we'll fill those in when we get to the bottom part of the page. But you have your other notes in front of you that you can refer to, and we'll talk them out here as we go. Sometimes nice not to have them in front of you as you're trying to work a problem, to force yourself to rely on memory, because that's what you'll have to do come test time. So let's start at number 28 here. We're going to be really boringly good at this factoring thing, even though we can probably tell by sight there may not be a GCF. We can tell how many terms because we're in the section on converting 3 to 4. But let's just go through it anyway, because when the problems get all mixed together, and that is happening soon, you will want to have this strategy, and that is there a GCF? Is there a common factor between all 3 terms? The answer is no. How many terms are we looking at? Well, no big surprise in this section here. We're looking at 3, which means we're going to convert to 4 so that we can factor by grouping. Okay, so we start by identifying the pieces here. We've got an A value of 9, a B value of positive 3, and a C value of 2, and it is positive, which means that we're going to be adding to find our strategic pair. So we take our A value times our C value. In this case, it's 9 times 2, and we get 18. And 18 is now what we're going to try to split, and we're going to try to add one of these pairs of factors to get 3. So let's list our factors here. What times what gives you 18? Well, 1 times 18, 2 times 9, 3 times 6. And now we're looking for a pair. Remember, it's a positive 2, which means we have to add them together to get our positive 3. And none of these add to give you positive 3. We get a 19, we get an 11, we get a 9. Be very careful. It would be tempting to go, oh, but I could subtract. Yeah, you could, but once you did that, you're not following the indication here. We're going to have to add. If you subtracted, you could happily work yourself to 2 factors, but when you FOILed it back, it wouldn't get you back to the original. So, and if you have time and are curious, you could test that out. But there's no pair here that adds to equal 3, which means that from that point right there, we can say that this particular one is prime. This will not factor out. So let's look at number 74 here. What's different about this one? Well, got some pretty big numbers, and we have some more z's. We're starting with a z cubed. Before you panic, remember, we're getting boringly good at this, and it's starting to pay off here. We check to see if there's a GCF. In fact, they all have a z in common. We're going to be able to pull that one out. In fact, they also have some numbers in common. We're going to be able to pull out a 20 here. So let's go ahead and do that. Let's do a GCF of 20z, leaving behind 4z squared plus 4z minus 3. 4z squared plus 4z minus 3. Now, this is just something I do to help me. Sometimes I've pulled out the GCF and I get so focused on factoring this 3 term that's left over, I'll write my answer for that and forget that this is a factor too, okay? So this has to be in our final answer. So I'm going to go ahead and just bring it all the way down right now. The GCF is part of the final factored form. It'd be like if we were trying to factor, I don't know, let's say 50, and we made it into 2 times 25, but then we forgot to put the 2 in the final answer. We just broke down 25 into 5 times 5 and said, great, the factors are 5 times 5. No, we have to pull out that. We have to bring down that first one that we pulled out as well. So we're bringing the GCF down. And now we look at what we have here. We've got an A value of 4, B value of positive 4, C value of 3, and it is negative, which means we're going to subtract our pairs to see if we can find the strategic split. So we take our A times C In this case, our 4 times 3, which is 12. And then we're going to split it. One and 12, 2 and 6, 3 and 4, and we're looking for a pair that will subtract and give us positive 4. And the pair that will subtract is our 6 minus 2. 6 minus 2 will give us a positive 4, which means our split, we're going to take that 4z and split it into 6z minus 2z, and the front one will be positive. 6 minus 2 will give us the 4. Then we bring down our originals. On either side, 4z squared minus 3, and there's our 4 terms. We've converted to 4 terms. And that was really the second question we should have asked ourselves. We got excited and got going there. How many terms? 3, which means we're trying to convert to 4. We've done that now. And now we look to see what the first two have in common, because we're factoring by grouping. And they have a 2z in common, leaving behind a 2z plus 3. Looking at the second two, again, the negative in front is our little tip-off that if we want an exact match, we need to pull a negative. If you forget, then they'll come out pretty close, but not an exact match. And then you remember, oh yeah, I need to pull a negative. So we know we're going to pull a negative. We look to see what these have in common. 2z and 3 don't have anything in common. It's known as being relatively prime. So 1 is going to be our GCF here. When you pull a negative 1 out, divide both by negative 1, you get a positive 2z plus 3, which is what we were expecting because we needed an exact match there. And then when you kind of pull back and look at what we've created here, they now have something in common. They have a big GCF, so to speak. So here we are at the bottom. Good thing I wrote my original GCF down, so there's one of the factors. Here's another one, 2z plus 3, and our final factor is what's left over here, the 2z and the minus and the 1. Okay. And that will now take some time to kind of copy all that, get your questions down, and then we'll move to the bottom of the page where we can fill in the steps and try one on your own.